Okay, this is number 126 of chapter 5. This problem's going to take a bit of time. This one's pretty complicated. A lot of stuff we gotta do, basically use all our tricks and tools that we have for triangles and trig in this one. So we gotta solve for the missing side lengths and the angles. So, there's a couple different ways you can do this. One way would be right off the bat, you could use the law of cosines to find this opposite side, right? So 17 squared plus 10 squared minus 2 times 17 times 10 cosine 45 equals that opposite side squared. So one way is you could use the law of cosines to find that opposite side. And then you could use the law of sines to find the angles. So that's one way. The other way is to kind of visualize, since we see this 45 here, the other way is to kind of visualize this as a 45, 45, 90 triangle, and then another right triangle attached next to it. So if you're someone who is like really comfortable using the law of sines and the law of cosines, I'll set up what that equation looks like for you. So we'll call this x, no matter how we solve it. So x squared would be 10 squared plus 17 squared minus 2 times 10 times 17 times cosine of 45. So that is the law of cosines. If you're comfortable with that, then that will allow you to find the value of x. And then once you have x, you could set up a inverse law of sines to find the angles. If you're comfortable with that. If not, maybe you'd rather work with right triangles. So that's fine. So let's say we got this right triangle. It's a 45, 45, 90. The hypotenuse is 10, which means each leg is 5 root 2, right, from using our special right triangle properties. Now I'm going to figure out what 5 root 2 is as a decimal. Let's see. Calculator disappeared on me. Okay. So 5 root 2, let's figure out the square root of 2's first. And then just multiply that by 5. So 7.07. So this whole side length here is 17. So we want to do 17 minus 7.07. 9.93, which is this length there. And so now we can do the Pythagorean theorem to find out what x is. So x squared equals 9.93 squared plus 7.07 squared. So let's see what that works out to be. 9.93 squared is 98.605. And then 7.07 squared is really 5 root 2 squared, and 5 root 2 squared is really 25 times the square root of 4, which is 25 times 2, which is 50. And I think we'll find if we do 7.07 squared, we get 50 as well. Okay, so let's just do that. 50 plus this 98.605 gives us x squared to be, I can memorize that, 148.605. And so we want the square root of that. So x equals 12.19. I'm guessing if you did the law of cosines, you would get something, or you should get the exact same. So 12.19 here. So there's the side lengths. So side length of 17, a side length of 10, and a side length of 12.19. Now we have to find the angles. So in order to do that, I'm going to have to find out what one of these angles is in the right triangle, since we have two unknowns here. And we can do that using some inverse trick. So we get to pick, since we have all three sides. You can use sine, you can use cosine, you can use tangent, it really doesn't matter. I'm going to use sine, so let's say the sine of theta, and I'll label this as theta there. So the sine is the opposite divided by the hypotenuse. So 7.07 divided by 12.19. So theta is then going to be the inverse sine of that ratio, or of that fraction. So let's see what that works out to be here. We got 7.07 divided by 12.19, and then we're going to take the inverse sine of that. So 35.45 degrees. So we had an angle of 45 degrees. We had an angle of 35.45 degrees. So to find this last angle, let's just use triangle sum. So 180 minus the 45 minus the 35.45 gives us this third angle to be is a 99.55 degrees. Okay, so that's a pretty intense problem, right? I mean, there's a lot of stuff going on there, regardless of which method you choose to do it. If you want to use right triangles, you can use right triangle trig, etc. Pythagorean theorem, triangle sum. If you want to kind of jump straight to the right answer, it's a little more challenging, but you can do that using the law of cosines and the law of sines. Any questions or comments about either of those methods, feel free to leave.